Hello everyone, hope you're doing well. So in this video, we are going to discuss about sacrificial protection. So in short, something is getting sacrificed over here. So in this, we are going to discuss about galvanized steel. So we know galvanization is nothing but coating of zinc on iron articles. So obviously, if we talk about steel, steel is also majorly iron. Then we do have some other elements also in it. Carbon, it can be nickel, it can be many other. So now galvanized steel, if we talk about, is a steel coated with more reactive metal zinc. That we are aware. That's a term. Zinc, like that is what galvanization is. Now, initially, if we say that if we have our iron article and then there is a zinc coating over here. So, initially, the layer of zinc prevents any contact of the inner steel, like iron or steel over here. So, with oxygen or water, if we say that initially, like we can't say that zinc has a zinc coating doesn't have a expiry date, right? So we can say that it's going to be its shelf life is going to be a lot, like it's going to protect steel pipes from corrosion a lot. So the whole process over here is happening because we want to stop corrosion of steel or iron from corroding itself, and that's why coating of zinc is happening at the first place. Now zinc doesn't corrode. Now what zinc is doing over here, that we are going to understand. So when the zinc layer is broken, so obviously at some point of time it will broke, it will break, like it is not going to stay till eternity. So if this zinc coating is going to break down, then obviously this steel, or you can say this iron, is exposed now. So what will happen over here? Zinc, which is more reactive than iron according to the reactivity series, so it will start getting oxidized. So more reactive metal zinc will form ions more readily, and electrons flow through it to the iron. So this is going to happen over here. Zinc is changing into Zn2 plus, right? So obviously some electrons are being lost. So these electrons are going to be supplied to iron or steel over here. So let's say majorly iron. So now in this, zinc is getting oxidized, but if we say this iron is not getting oxidized, why? Because it's getting supplied, it's you can say it's getting electrons which are from zinc itself. So zinc is losing electrons, so the supply of electron is already there for iron. So iron need not to be oxidized over here. So oxidation of iron will not happen, and if iron is not getting oxidized, definitely corrosion of iron will not happen. So if you have seen my previous videos in chemical reaction and equations where I've discussed about corrosion, so iron needs to obviously get oxidized, and there is moisture also, and it changes into this Fe2O3 dot X molecules of water. This is rust. So this now this what is happening over here? So more reactive metal, which is zinc, which is forming ions more readily, and electrons flow through it to the iron. That is happening. So this attracts hydrogen ions from the water. Obviously, if zinc coating is getting degraded, so moisture is there, water is there. So water can supply H plus ions, and in this whole process, I'm not writing the detailed equation, just remember that since water is supplying H plus ions, so definitely it is going to release hydrogen gas. So in this entire, you can say, process, zinc is getting oxidized, but iron is not. So zinc loses electrons. Loss of electron is oxidation, that we discussed in the previous videos also if you have watched. So iron accepts electrons on or on its surface, so it does not lose electrons, so it is not getting oxidized. So, more reactive metal does not need to coat the steel completely, but you can say uh, it does need to be in electrical contact over here. So we can have let's say any large steel structures are there, like pipelines or ships are there, so they can be protected from corrosion by attaching some bars of zinc. So we can say that in this entire discussion, that zinc is getting sacrificed to protect steel. So this kind of you can say this kind of process can be done with magnesium also. It's not only with zinc, but we can attach magnesium bars, so magnesium will also do the same job. So this is how sacrificial protection is very much useful for any kind of metals where corrosion can happen, and suitable, the best is for iron. And this example is best, you can say, explained with zinc, so we can do with magnesium also. So I hope you have understood. So if you like and if it was helpful, then please do like, subscribe, and share. And do comment also. I never mentioned that before. Like, you can also comment if you like any video, if you want me to add some specific videos. So I believe in a certain way that I really want to build a base. So some people say that, okay, we already have a base, so we need to learn the higher one. So I'm working on that, but it will take some time. But yes, if any point of time you feel that your base is not clear, you can watch some basic videos about anything, whatever I've uploaded. So in the future also I'll be keep on uploading, so you can watch videos over there. And sometimes we don't understand a thing in a, you can say, in the first watch, and you can repetitively watch it again just to understand it in a better way. Just like you read a book and you understand somewhat, you can say, in the first time, but when you start reading it the second time, you understand it better. And every time you read it, there is a different kind of meaning that will come to your brain. There will be different kind of thoughts that will be coming to your brain, so it always help. So thank you.